For the last decade, almost every concept for an autonomous car has arrived with the exact same picture attached. The front seats are swiveled inward, there's a wooden coffee table in the center, a plush rug on the floor, maybe even a potted plant. The promise is simple. The car is becoming a living room. But there is a major blind spot in this conceptual phase. Inside rendering software, a slab of solid oak has no mass. An unbelted passenger facing backward carries no kinetic energy. The physical requirements of the machine simply don't exist yet. Meanwhile, there is an entire industry that actually builds living rooms on wheels, and they have spent the last 60 years calculating exactly what those choices cost in the real world. Yet the automotive designers drawing these sociably soft, inward-facing cabins have largely ignored the engineering lessons forged in places like the Dusseldorf Caravan Salon. When you design a room without acknowledging the physical forces acting on a moving vehicle, you end up operating in a vacuum. Your aesthetic choices become completely detached from the manufacturing constraints of the platform. The first hidden boundary you hit when designing a mobile lounge is a strict legal one. It's the relationship between the vehicle's total weight and the piece of plastic in the driver's pocket. In Europe, a standard license allows a maximum authorized mass of exactly 3,500 kilograms. Cross that line, and standard drivers are legally barred. Car manufacturers fight over mass for battery range, but in caravanning, every kilogram dictates sheer legal access. Add a heavy piece of furniture to your design, and you are actively deciding to shrink your product's total addressable market. Then you run into the second cost. Moving a heavy, lounge-equipped vehicle often changes the legal parameters of the journey itself, significantly dropping the maximum speed allowed on the highway. But the most unyielding constraint is what happens during a collision. Car interiors are drawn under the assumption that every surface within reach must answer to the Euro NCAP crash testing pulse. A swiveled seat, a loose cushion, a heavy central table. During a sudden deceleration, these utopian features turn into enormously expensive and fatal liabilities. The caravanning industry functions by separating these two states. The vehicle is a machine for driving and only becomes a living room once completely parked. Autonomous concepts are attempting something much harder. They are trying to merge a high-speed machine with a stationary room, a complex engineering hurdle that no one has actually figured out how to solve. There is a $159 billion economic force driving this space in the United States, and the median age of a new RV buyer is now 32. This age group mirrors the primary target for autonomous tech concepts. This demographic alignment suggests the auto industry should look to these established players to learn when to make the decisions that enable a lounge on wheels. In the caravan industry, these choices are integrated upstream. They use sandwich panel construction where the interior cabinets and bed frames act as the load-bearing structure of the vehicle itself. If you sketch the rug and the coffee table first without calculating the structural mass, you will spend your entire development program discovering what that failure costs downstream. A living room on wheels requires a foundational physics package locked in on day one, as opposed to an aesthetic layer added at the end of development. This is why Depix design intelligence operates entirely within that vital first window of creation, where a lounge is still a calculated package decision rather than just a beautiful digital rendering. Because when you ignore the physics to draw a perfect picture, you are drafting a manufacturing disaster.